Look up at the sky, past the clouds, through the stratosphere, far above even the highest flying satellite, lies an idea so bold, it could rewrite the rules of space exploration. A structure so tall, it would stretch over 35,000 kilometers from the surface of Earth, all the way to space. This isn't science fiction, it's a real concept with real engineers trying to make it happen. It's called a space elevator, and one day, it could carry humans and cargo to orbit without using a single drop of rocket fuel. So the question is, when will we build it? The idea of a space elevator might sound like something from Star Trek, but the original version came from a Russian scientist, Konstantin Tsiolkovsky, back in 1895. He imagined a giant tower reaching geostationary orbit, a point 35,786 kilometers above Earth where satellites stay fixed above a point on the ground. Later, the concept evolved. Instead of a massive tower, a cable or tether would be stretched from Earth to a counterweight in space. Along this cable, robotic climbers, powered by lasers or solar energy, would ascend and descend, carrying cargo and even humans. It's not science fiction anymore. NASA, JAXA, and private companies are actively studying it. So what would it take to build one? First, the material. The space elevator's tether must support its own weight, plus the weight of everything climbing it. Steel? Not strong enough. The best candidates? Carbon nanotubes, graphene, or some future synthetic material we haven't invented yet. Carbon nanotubes are 100x stronger than steel and incredibly light. But we can't yet produce them at the needed length or purity. We'd also need a massive anchor station on Earth, a counterweight in orbit, a network of laser or magnetic propulsion systems to move climbers. The scale is unimaginable, but not impossible. So why bother? Why not just keep using rockets? Because space elevators could change everything. Right now, it costs $10,000 or more to send 1 kilogram into space. A space elevator could reduce that to under $100 per kilogram. That means massive satellites at a fraction of the cost. Space tourism becomes practical. Lunar and Martian missions supplied regularly. Permanent orbital habitats resupplied without rocket fuel. In the long term, it could enable a true space economy, with mining, factories, and even farms in orbit. Of course, it's not all smooth climbing. A space elevator faces major risks. Space debris could cut the cable. Weather and storms could damage the base. Oscillations and vibrations could cause collapse. And if the tether snaps, one end could whip around the planet, destroying everything in its path. Safety systems would be needed to handle the unimaginable. That's why many scientists believe the Moon or Mars would be better test sites. Lower gravity, no atmosphere, and no debris make them ideal, and several lunar elevator designs already exist. So, when will we build it? Japanese firm Obayashi Corporation claims they could build one by 2050. NASA has ongoing research into elevator climbers, and startup companies are working on graphene scaling and space tether experiments. A lunar elevator may happen as early as the 2040s. A full Earth-to-orbit elevator? Likely sometime near the end of the 21st century, if we can master the materials. The space elevator sounds like a dream, but many of today's realities once were. If we master the material, solve the energy, and protect it from debris, we'll open a permanent bridge between Earth and space.